All right, day 4, volume of a cone. You may notice that these first two shapes are not cones, and you would be correct. The reason they're on there is because I want to show you that the pattern, or I should say the analogy maybe, a pyramid is to a rectangular prism as a cone is to a cylinder. So what do I mean? Let's compare our rectangular prism and the pyramid that I've drawn here. What would be the volume of the rectangular prism? It would be 4 times 4 is 16. The area of the base is 16. 6 layers of that. 16 times 6 is 96. So that's 96 centimeters cubed. How about the pyramid? Well, it's the same base. The base has an area of 16, same height. 16 times 6 is 96. But remember, it's 1/3 of that number. The pyramid is 1/3 of a rectangular prism with the same dimensions. So this is 96 divided by 3, which is equal to 32 centimeters cubed. So it's 1/3. And when it comes to a cylinder and a cone that have the same dimensions, which these do, a radius of 3 and a height of 6, it's the same thing. Whatever you get for your volume of your cylinder, your cone is going to be 1/3 of that. So what is the volume of this cylinder? Well, it's area of the base, which is a circle, and the area of a circle is pi r squared. So you square the radius, r squared. So you get 9 pi for the area of your base, and you have 6 layers of that. 6 layers of 9 pi, that's 54 pi. So the area of that cylinder is 54 pi. Now the cone has the same dimensions, so you're going to get 54 pi again, 9 times 6, but it's 1/3 of that. 54 divided by 3, yes, is 18. So it's 18 pi inches cubed. One thing that I see a lot on this test are people messing up the pi, either forgetting to put it with the cylinder and the cone or adding it into the rectangular prism and the pyramid. You don't use the pi symbol if there's not a circular shape in your shape. So there is no circle in a box or square-based pyramid. There is a circle in a cone and a cylinder. So you use pi in these two. You do not use pi in these two. You only use pi when there's a circle involved. And now there's a couple other types of problems that could be a little bit trickier. In this first example, they don't give you the height of the cone. They give you the length going up the side, the diagonal length. So you have to figure out the height on your own, and that height is going to make a right triangle with the radius and the side of the cone. So you'd have to use Pythagorean theorem. 25 and 9. Does that make 34 or does that make 16? Do you add those together or do you subtract them together? You add them if you're looking for the hypotenuse. You subtract if you're looking for a leg. A leg is a straight side of a right triangle. The height is a straight side. You're looking for a leg of the right triangle. Therefore, you're going to subtract the squares of those numbers. 25 minus 9. So that height is equal to the square root of 16. 25 minus 9, which of course is 4. So your height is 4 in this one. So the area, or I'm sorry, the volume of that cone would be 3 squared pi times 4, and then divide by 3, remember, because it's not a cylinder, it's a cone. So you get 9 pi times 4 is 36 pi, and that would be the answer if this was a cylinder. But it's not, it's a cone, so it's 1/3 of that. It's actually 12 pi inches cubed because you had to divide 36 by 3, or you could say you multiplied 36 by 1/3. Either way, you get 12. All right, another variation. You might not have to solve for volume. It might already give you volume and ask you to solve for one of the dimensions, in this case, the height. So how would you solve for the height in this? Well, the volume is pi r squared times h. So you're basically solving for h. You're getting pi r squared to the other side, which means you have to divide it to the other side of the equation. So your volume divided by pi r squared equals to h. So those of you that like algebra, that's how you would do that. You would substitute in 100 for volume. You would substitute in 5 for r and square that. and you would get 25, and then you would divide, and you would get 4. All right, let's see here. So I like to kind of do these in my head. If you look at this and you say, all right, what is the area of the base? Its area of the base is 25 pi, and our volume is 100. What do you have to multiply 25 by to make it 100? You have to multiply it by 4. So your height is 4. All right. So I don't know if you're going to run into those two on today's work, but eventually someday in your schooling career, you will have problems like that. So it's good to be able to manipulate the formula to solve for one of the dimensions. You're not always going to be solving for volume, even though in today's work you probably will be.